Good afternoon, everybody. Thank you for your time today. I want to talk about where we are with L2s in the Ethereum ecosystem and where we are going. But let me start by talking about why we're doing layer 2s at all. There's a lot of discussion about layer 2s, good, bad, or indifferent. I'm a big supporter of layer 2s, and let me explain why. Of course, the story of layer 2s on Ethereum starts in 2020 with Vitalik's now famous post about a roll-up-centric roadmap for Ethereum. This is where the Ethereum Brain Trust first committed themselves to an L2-centric strategy. This, in my mind, was a brilliant move because it took a lesson from the internet, which is the most successful, largest-scale, decentralized, credibly neutral technology that's ever existed. The reason that this has been such a great idea for the internet is that it allows innovation to develop. It allows each layer to specialize in doing one job. And the internet has been incredibly successful at innovating and evolving and pivoting over time because of the decision to build in layers. And Vitalik was taking a lesson from that. And I think it's been incredibly successful. Let me just give you some statistics about how much layer 2s have allowed the Ethereum ecosystem to grow. Layer 2s today do about 30 times the transactions per second of layer 1 Ethereum, about 40 times the data, about 80 times the total gas usage, and there are now well over 100 layer 2 and layer 3 chains. Just to emphasize this, let me show you a bar graph that shows transaction activity in the Ethereum stack categorized by layers. You can see that layer 1 accounts for only a couple % of the overall usage. Almost everything is at layer 2 and at layer 3. This has been one of the great strengths of layer 2 and layer 3 technologies. They've expanded the scope, the capacity of Ethereum by a tremendous factor. But equally important, just like the internet, the development and use of layers allows customization of each technology of each chain. It doesn't have to be all the same. Each chain can be customized for a particular application or use case or business model. And so the L2 roadmap has been incredibly successful. But how can we continue to grow it in order to grow Ethereum? The most important thing, I think, is to make sure that L2s are aligned with Ethereum. And to me, Ethereum alignment means just this, that we work every day to make the Ethereum stack faster, cheaper, more reliable, and easier to use. If we're doing that, we're aligned. So how can we make it faster? Well, here there's a bunch of things, and there's active work going on from many teams. First, developing benchmarks so we have standardized ways of measuring performance and knowing how well we're doing. Second, faster execution, making faster virtual machines so that we can do more work on the same nodes. Next, parallelism, the ability to discover and take advantage of parallel transactions that can be executed at the same time to provide the same result as if things executed in sequence, but to take advantage of parallelism to make it go faster. To be smarter about resource pricing so that we can continue to operate chains closer to the red line of the nodes. And then finally, to build horizontal scaling so that we can have more chains that work together harmoniously to provide a single and clean user experience. Work is going on in our team and many other teams to pursue all of these strategies to make the Ethereum stack and individual chains faster. So what do developers need in order to play a role in building out applications on this faster chain? They want a few things. They want to be able to use familiar, standard, battle-tested languages and tools. They want to have fast execution at the speed of native code on the nodes. And they want all of this, these new models, to be fully composable so that they don't have to program in separate silos for EVM versus non-EVM code. Arbitrum provides this via Stylus, which allows developers to write on-chain applications in many different programming languages, Rust, C, C++, and others, and deploy them onto an EVM chain with full composability, and best of all, running at 10 to 20 times faster than EVM code, or 1/10 to 1/20th the amount of gas. There are many applications already taking advantage of Stylus. This is available natively on every Arbitrum technology chain now. Horizontal scaling is equally important, the ability to grow and increase the number of chains so that we can have more activity running through the natural or parallelism of having multiple chains. And in the Arbitrum network, you see this as well. Many chains working together, not only expanding capacity, but also providing customization for particular use cases. For example, gaming chains put a lot of focus on having a fast block time, very fast response time. Other chains may be customized for RWA applications and so on. There's not only strength and speed in this, there's also diversity. What can we do to make the operation of these chains cheaper? Really, we need to do two things in tandem. First, we need to lower the cost of operating the chain. If we can lower the cost of operating the chain, then we can lower fees for users in a way that's sustainable, because a chain needs to be economically viable. That is, it needs to be able to take in fees enough to cover the costs of operating the chain. And so we're working every day to figure out how to lower the cost of operating the chain to allow to do the same work on cheaper nodes and to be able to get more done. Really important here is better pricing. Pricing of on-chain resources is the way that chains make sure that they're not going too fast, that the user activity, the applications happening, don't overwhelm the capacity of nodes. So a pricer is really the mechanism that decides how well utilized the nodes will be. And if we can improve on-chain pricing, we can avoid hitting the brakes on the chain to slow it down unless we really need to protect the capacity of nodes. And you'll be seeing some really interesting announcements from our Off-Chain Labs team along this direction soon. What can we do to make Ethereum more reliable? Well, here, there's no one brilliant idea. Reliability comes from working hard every day, from doing our engineering and being heads down and making sure that we test and design and plan for reliability. I want to take the bulk of my time in this talk to talk about what we're doing to make the multi-chain L2 environment on Ethereum easier to use. We have many chains, and we've provided a great deal of expansion of capacity and diversity by increasing the number of chains. But in order to provide the user experience that people want, we need to be able to connect all of these chains together. Because users don't benefit, they don't find it easy if they have to see the boundaries between chains, if moving between chains means many clicks and a long delay. We need to connect everything in a way that is fast and trustless. Our goal is to develop a mechanism that can allow seamless cross-chain activities across any Ethereum-based chain in a fully trustless way at a latency of 3 seconds or less. And we believe we know how to do that. So, how do we do that? Well, again, we take lessons from the internet. The internet, again, is the most successful, largest scale, fully interoperable technology that humanity has ever built. So how does the internet achieve great interoperability? First, it focuses on being fast. Second, it is standards-based. On the internet, products developed by different companies, different teams, can work together because the standards are carefully designed, carefully negotiated among the teams to allow them to talk to each other and to provide the experience that users want. Taking a principled but also practical approach to standards development is key. Third, interoperation on the internet is asynchronous. That one device, one machine, doesn't stop and wait for the other one. Why don't you stop and wait? Well, you don't know how long the other one will take. You don't know if it's even there. So asynchrony, the fact that you don't tie the timing together, that although the human may stop and wait, the machine never stops and waits. It goes off and does something else. Next, fault tolerant. This is really important. If you're going to have a large, independently operated and diverse ecosystem, you need each part to be tolerant of failures from the other parts. And that means that one chain can't just assume that other chains are going to be there, can't assume that another component is going to be there. You have to be able to react and cope and switch over to a backup strategy if something is not working. And then finally, internet interoperation is security conscious. That is, one component, for us, one chain, one mechanism, doesn't just assume that another one is secure, but instead each component defends itself against the possibility that something will go wrong. These last three bullets are the most important. On the internet, no component assumes another one will respond immediately, no component assumes another one will never fail, and no component assumes that another one is perfectly secure. Everyone looks out for themselves and cooperates in a proactive way. And this is what we need to do as well. So, on the Off-Chain Labs team, we've been working with the Arbitrum community and the Ethereum community to develop what we call the Universal Intent Engine. And this is a mechanism that is designed to support the interoperation that we think is needed to drive cooperation and drive a smooth user experience across a diverse L2 and L3 ecosystem. And I want to talk a little bit about how this works. Dive into the technology just a little bit. So let's talk first about the user journey. What is it like for the user to use the Universal Intent Engine to, let's say, move assets from one chain to another, or take an asset that's on one chain and use it to do a swap on another chain? So the user starts out, the user first creates an intent. That is, the user says through their wallet or some other user interface that I want to do this operation. I have some asset over here. I'd like to have that asset over there on a different chain. So the user creates that intent. They click something in their wallet. That intent is then registered. The intent is formatted for the intent feed. It's then published in the intent feed, which goes out to all the parties all over the world who might be able to satisfy that intent by providing the funds on the destination chain, presumably in exchange for a small fee. So that goes out in the intent feed, and the user's funds on the source chain go into escrow. They're locked in a smart contract. Now, there's a cross-chain settlement mechanism which allows the user's intent to be satisfied by a filler or provider, a solver, someone who is able to provide what the user asked for over on the destination chain. The cross-chain settlement mechanism ensures trustlessly and quickly that the funds actually have been provided on the destination chain. And then, within a few seconds, the cross-chain settlement mechanism tells the escrow contract to release the funds, and these funds that the user provided in escrow on the source chain will go to the solver, but only after cross-chain settlement has trustlessly guaranteed that the intent has been satisfied. What does it look like on the solver side? Well, the solver is listening to the intent feed. If I'm a solver, I'm able to provide funds to users on destination chains in exchange for a fee. So I'm listening to that intent feed. When I see some intent, I see the user say, I have funds over here, I'll pay over here. I'd like to receive funds over there. I, as a solver, might say, okay, I can satisfy that. I then send a quote back to the intent server. Say, I will satisfy this in exchange for a fee of, say, 0.02%. If I'm chosen by the mechanism to provide those funds for the user, presumably because I was the lowest bidder among the parties who have been reliable in the past, then I participate in the cross-chain settlement protocol. I take the funds that I'm going to pay to the user, they go into escrow on the destination chain, and now the cross-chain settlement mechanism takes those escrowed funds, pays them out immediately to the user. Then a message is sent across to the source chain where I'll receive on the source chain. So we believe that we can provide this. The magic is in the cross-chain settlement protocol here, which is able to guarantee atomicity so that the two sides work together and that neither one happens unless the other one has performed as required. We can provide this, we can provide it trustlessly and very quickly, and you'll be seeing some announcements about that as well from our team. So the key to advancing Ethereum by advancing L2s is to be aligned with Ethereum to work on faster, cheaper, more reliable, and easier to use. If we do this, we can ensure that the future of L2 is the future of Ethereum. And we can uphold the Arbitrum principle, which is your chain, your rules. Thank you.